Those were ionic compounds where the electrons were transferred. Covalent, we talked about covalent means sharing valence electron. So here, when we have nonmetals and nonmetals forming bonds, we have electrons being shared. The ionic compounds work with the transferring, because the metals would like to get rid of electrons, the nonmetals want to get electrons, and so they can cooperate that way. But here you have two nonmetals, and they both want to gain electrons. And nobody's willing to give them up and form a positive ion. So they get around that by sharing. So in Lewis theory, we represent that by sharing valence electrons between the two atoms. So let's look at hydrogen and oxygen. So hydrogen has how many valence electrons? Has 1. And oxygen has how many? 6. Hydrogen's not willing to give up its electron. Oxygen wants another electron. Hydrogen wants another electron. They're both nonmetals. What they're going to do is they're going to share. So these two electrons are going to be shared. When they're shared, they count for both. My husband and I have 6 children. Good, it's still shocking to me, 6 of them. If you ask me how many children I have, I would say 6. If you ask him, how many children do you have? He would say 6. They're the same 6 children, right? There are 12 in the house. That would be really, really crazy. There's only 6. Only 6. But they count for both. So when these guys are sharing electrons, the hydrogen is sharing an electron with the oxygen, but the hydrogen counts both of these. And the oxygen counts both of them. Because when you share, it's like you've got more stuff, right? So the hydrogen thinks it has 2 electrons now. That's the duet rule. The hydrogen wants to get 2 electrons because now it's like helium, which is the closest noble gas. Is the oxygen happy yet? No. It's getting better. Its mood is improving, but it's not happy yet. So what's going to happen is we're going to have another hydrogen atom over here with 1 valence electron, and these guys are going to share. So now the oxygen has a total of 8 valence electrons, including the ones that it's sharing with each hydrogen. Each hydrogen counts 2 valence electrons. So they share their electrons. The hydrogen atoms get a duet, and the oxygen atom gets an octet. Any questions? Here's another illustration with circles. Kind of looks like a Venn diagram. So here's the hydrogen. And here we're drawing these in a more regular way. So here's the hydrogen, and there's 2 dots between 2 electrons between the hydrogen and oxygen. Those are shared. And here's 2 between this oxygen and the other hydrogen, and those are shared. And so the hydrogen is counting those shared electrons, and this hydrogen is counting both of the shared electrons. The oxygen is counting these shared electrons, those shared electrons, and these that are not shared. And so the oxygen feels like it has 8, each hydrogen feels like it has 2, and everybody's happy. If only life were that simple, right? So we have 2 different kinds of electrons here. We have bonding pairs and lone pairs. If we look here, what we call a bonding pair, that's a pair of electrons that are shared between 2 atoms. That represents a covalent bond. So there's a bonding pair, and over here is a bonding pair. Those are shared. This pair of electrons on the oxygen and the one on the other side are not shared. They're alone. So that's a lone pair. The lone pair, or a non-bonding pair of electrons. So there's bonding electrons and non-bonding. We often show the bonding electrons as a dash between. That dash represents 2 electrons, a pair of electrons. If you've noticed, everything's pairing up, aren't they? So that with the lines is a little bit like what we drew on the other slide. So you can imagine the lines as being, we've connected those dots. So a line is 2 electrons connected into a line. So every line is 2. Lewis theory helps us to understand those diatomic elements. Remember those 7 horses need oats for clear brown eyes: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Let's look at bromine. This is going to help us understand why bromine makes a Br2 molecule. So bromine is Br, and we're going to have another one over here. And each of them has 7 valence electrons. Neither of them has an octet by itself, so they're not happy. But if you get 2 of them together, we could have them share a pair of electrons, and now they're happy. They've got an octet. Okay, obviously, atoms are inanimate objects, and they can't be happy or sad. But that's a lower energy state, and so that's something that's favorable, because lower energy is like a ball rolling down a hill. Okay, things are going to go to the low point. Lewis theory also predicts that hydrogen exists as a diatomic molecule. Let's look at hydrogen. So hydrogen, each hydrogen has 1 measly electron, but if they get together and share, then they each have a duet, right? And that's you know, hydrogen doesn't have real high aspirations. He's just trying to be like helium. He couldn't handle 8 electrons even if you gave it to him. He's just too small. It'd be a giant jacket on him or something. I don't know. So that's atoms sharing a pair of electrons. Atoms can share more than 1 pair of electrons. So let's look at oxygen. Oxygen is another of those diatomic elements. So let's look at what happens with oxygen. How many valence electrons does oxygen have? 6. 1, 2, 3, 4, 5, 6. And this is also oxygen, and it has 6. Well, if all you've got is oxygen, how can they help each other out? How can they share so that everybody's happy? Well, they could share these electrons here. So this is better, right? But do they each have an octet? No, they each have 7 now. So they're going to share another pair of electrons. So we could draw that like this, with 2 lines representing 2 pairs of electrons that are being shared. Those are 2 bonding pairs, and then each of these is going to have 2 lone pairs. So when we're looking for octets in these Lewis structures, we have to recognize that each line is 2. So that's 2, 4, this pair is 6, and 8. So this oxygen has an octet, and this oxygen has an octet. Let's draw circles. So that's what this one counts, and that's what this one counts. So those shared electrons get counted twice, and that's how they can each have an octet, even though there aren't any more electrons than what they started with. Any questions? Yes?
How do we know which way to write it? Like, do we write it that way or the way with the brackets?
Okay, that's a good question. Do we write it like this or with brackets? The brackets are for ions. And so ions happen when you transfer electrons. This is sharing electrons. So the brackets and the charges will happen if you have a metal and a nonmetal. If you have 2 nonmetals, then you'll have sharing. Good question. Any other questions? So that's called a double bond. A double bond is two pairs of electrons being shared. Okay, single, one pair, double, two pairs. Double bonds are shorter and stronger than single bonds. The distance, just as an example, if you look at oxygen nuclei, if there's a double bond, the distance between the nuclei, which is equivalent to the bond length, is 121 picometers, and a single bond is 148. So by sharing two pairs of electrons instead of one, that pulls those atoms closer together, and it also creates a stronger bond between them. So I guess me and my husband have a really strong bond then, because we've got 3 pairs of children between us. Let's look at nitrogen. Do the same thing for nitrogen. So here's N, wrong color. N and N. How many valence electrons does nitrogen have? It's got 5. Group 5A, it's got 5. So this one has 5. And I'm just drawing them this way because it's convenient, because I'm anticipating what I'm going to do. So nitrogen is another of those diatomic elements. Nitrogen gas is N2. Why is it N2? Well, the nitrogens can share one pair of electrons here. Now they each feel like they have 6 electrons. They can share this pair. Now they're up to 7. And they can share this pair. Now they're up to 8 electrons each. So we can draw that with the lines over here. 3 lines. That's a triple bond. Single is 1, double is 2, triple is 3. How cryptic is that? And then we have lone pairs over here. So this nitrogen, and these circles, we don't normally draw them when we're drawing Lewis structures. I'm just drawing them to show you those are the electrons that atom is counting. And these are the electrons that this nitrogen atom is counting. So this one counts 2 for the lone pair, 4, 6, 8. Each line is 2. And this nitrogen has 2, 4, 6, 8. And so by sharing 3 pairs of electrons, they can each have an octet, and that's a favorable energy state. Yes?
For master chemistry, those dots, does it matter where it has to be? Or
No. That's a good question. Does mastering chemistry care where the dots are? No. It does care whether you pair them up or put them singly. Okay? So they're pretty much going to be paired up in compounds. Okay? The only time they're not going to be paired is when you violate the octet rule, which we'll talk about a little bit later. But if you drew the dots on the sides or on the top or on the bottom, as long as they were both together, it's fine. It's a good question. So that's a triple bond. The triple bond is even shorter and stronger than the double bond. If you look at nitrogen bond lengths, a triple bond is 110 picometers, a double bond is 124. So by sharing more electrons, it strengthens the attraction, it pulls those nuclei together. So nitrogen is a very inert gas. Oxygen burns. Oxygen's more reactive, and hydrogen is reactive. Nitrogen is pretty unreactive because it's got that really short, strong triple bond that's hard to break.